Hello, today we are going to talk about restaking, or more in general, programmable staking, and its implementation in EigenLayer. In this period, we are seeing a lot of discussion on second-order effects like the economics, like liquid restake tokens, like the risks of EigenLayer. I wanted to make the point and start from first principles, understanding first of all why we need programmable staking, how does it place in the space of different options for achieving cryptoeconomic security, and how it actually works then in its implementation in EigenLayer. So we'll go look at how programmable staking is implemented or restaking, and what are the different stakeholders in EigenLayer. It's very important to know who are the actors and how they interact. And then we're going to give more details on looking at EigenLayer as a coordination layer, as a marketplace for trust, seeing the difference between pooled security and attributable security, and finish with applications like examples of AVSs and dual staking. But let's start from the very beginning, the why. So I think it's important to start from the idea of understanding why do we even need decentralized trust. Because you are hearing, and you will hear many times, that restaking is a way to access decentralized trust. But then, all right, what's the point? So the thing here is that to provide decentralized, we believe that decentralized applications can provide a different kind of value to the user. So we'll build applications that provide value that cannot be achieved with centralized counterparts. I'm not saying that there is no space for centralized applications, but at the very least, there are going to be different applications or a different kind of value. So that's the idea. That's why we are here, because we believe decentralized applications can provide at least a different kind of value that has its own purpose. But then, how do you build decentralized applications? To achieve decentralization, you have to build on top of a decentralized trust layer. And that's the trick. That's where EigenLayer plays a role. EigenLayer and programmable staking, more in general, is a way to access this kind of decentralized trust. Of course, it's not the only way. There are trade-offs, and we can discuss for long on that, but that's the starting point. That's why we need decentralized trust. At the end of the day, it's to provide value to the end user, all right? Then, as I said, programmable staking, again, is not the only way. We have been building or try to build decentralized applications that provide actual value to the user in different ways. So let's say you're an application developer and you want to build a decentralized application because you really care about the kind of value that can be provided in a decentralized way, as it's a different kind of value. You want to differentiate, and you know this is the best way to provide that value that you care about. So at this point, you as an application developer, you have different options. You need this decentralized trust, but how do you get it? And there are different options with different trade-offs. And one option is what I wrote here as you can deploy an independent system fully relying on your own cryptoeconomic security. So think about layer one, a new layer one chain. You have an idea, you create an app chain, or anyway, a layer one chain with its own token, its own validator set, its own cryptoeconomic security. You can do that. Now, of course, there are trade-offs. So you have to consider, is this really the best way to access decentralized trust? Is this what I need? Is it an overkill? So you can then consider other options. So this is not the only way. Just build a big layer one. You can use you can go for a consumer chain on the Atom economic zone. You can use a parachain or a hyperchain, a rollup, like a classic rollup on Ethereum, a Validium, an Optimium, sovereign rollup, Celestia. Many more options. Or maybe, in your case, the best way could be to just develop a program on any of the above, like a smart contract system, on a layer one, or on a rollup, and so on. So there are different options already. The thing is, The AVS, and now programmable staking and this concept of AVS that we're going to look at, that was introduced by EigenLayer, proposes a new option. Okay, so you evaluated all the options. You thought about, okay, maybe I can build a layer one, maybe I can build a consumer chain, maybe a rollup, maybe just deploy a program on Solana, any. And at the end of the day, nothing works as good as this new option, potentially, all right? So let's see this new option. This new option is to deploy an AVS secured by programmable staking. What is AVS? AVS is an actively validated service. And I'm taking the definition now directly from EigenLayer. So AVS is any system that requires its own distributed validation semantics for verification. There are a few keywords here, and of course, distributed is important, because if you don't need decentralized or anyway more actors participating into validation, then what's the point? So it has to be distributed, and it has to have its own validation semantics, validation rules. You need, this makes sense if you have a set of validators that have to agree on the validation rules. So, it's a very generic definition, and it can be pretty much anything in our decentralized world. But we'll see that it makes more sense for certain kinds of applications. But in principle, actively validated service is really a very generic definition. Then we need to know what is programmable staking, because this new option is you build this AVS thanks to, it is enabled by programmable staking, or is at least secured by programmable staking. So what is that? Programmable staking means a set of rules for custom locking and slashing conditions for pretty much any asset. That's the programmable way. Normal staking, normally, it's secured, or anyway, there are locking and slashing conditions on a native asset issued by the same system that wants to be secured by this staking mechanism. Here, you have custom locking and slashing conditions for any asset in principle. And it makes sense if it's not natively issued by the same AVS. So the AVS, in some way, is going to rent cryptoeconomic security from another asset that is not natively issued by the AVS. This is what programmable staking is, and then we'll see more in detail the implementation in EigenLayer. So as a result, the AVS acquires decentralized trust from the civil resistance and accountability properties of the programmable staking mechanism. So this is like in normal proof of stake, why proof of stake makes sense to build decentralized trust, because it provides civil resistance, and in some cases accountability properties in the sense that you can rely not only on positive incentives but also on negative incentives if something goes wrong or if you try to attack the network. That is slashing. So at this point we could develop much more like what are the trade-offs here, why going for an AVS, why going for an independent layer one or a rollup. But that's a long discussion that we can do another time. But some clear advantages of an AVS secured by programmable staking is that it's easy to bootstrap. You don't have to build your own set of validators, for instance. You don't need to rely on your own token. So easy to bootstrap, flexible, because you don't need to rely on your own token. And stable, also for this way. Because if you rely on your own token, then the market price of the token might affect your cryptoeconomic security too much. And if you can rely on other assets because you have programmable staking, then you can stabilize it some way. So these are some general benefits of deploying an AVS with programmable staking. And also what I want to say is that what you got is cryptoeconomic security. So this decentralized trust layer for an AVS is really cryptoeconomic security, similar to what you get in proof of stake. But cryptoeconomic security is not everything. Like a full independent layer one, it also keeps the benefit of social slashing, forking. So it's not exactly the same. And again, we can talk forever about trade-offs and options, but this is what the AVS with programmable staking gets you. So I was saying An AVS can be pretty much anything. If you read the definition, it's very, very generic. But what you will find out looking at the first applications in EigenLayer, and it's also very clearly stated, I mean, it's not like it's not obvious, is that AVSs are particularly suited for middleware. So you will see in the stakeholders that the AVS has as consumer a decentralized application. So it's not the end user using the AVS, but it's a decentralized application using an AVS. AVSs are particularly suited with programmable staking, are particularly useful for middleware. So it's somewhere in between the decentralized trust layer is providing security to the AVS, and the AVS is providing extra services to the decentralized applications. We will see at the end of the presentation the concept, for instance, of restaked rollups. And restaked rollups are rollups that have like superpowers thanks to certain AVSs that really improve the rollups in a certain way. So that's where the AVS makes more sense, but it doesn't mean that it has to be here necessarily in the middle. Okay, then let's move to EigenLayer more specifically. And the term that you hear more often is restaking, but more in general, we need to talk about programmable staking. Now, why do we talk more often about restaking in EigenLayer? Because we talked about the generic definition of programmable staking. When you go more specifically in EigenLayer, at least at the beginning, the eligible assets that can be put at stake are staked ETH, so Ether that has been staked, and LSTs, so liquid stake tokens. In both cases, you have an asset that has already been staked, means that it already has a certain set of slashing conditions defined by the Ethereum staking protocol. That's why we talk here about restaking, but in general, it's still programmable staking. It's an implementation of programmable staking. Then what else about the implementation details, let's say? EigenLayer is implemented and enforced by a set of smart contracts on Ethereum. So it's a smart contract system. And what do these smart contracts do? First, you have the AVSs themselves that define a set of validation rules. That's the work that you need to do. And the slashing conditions, like your assets are at stake, and if you break the rules, if you trigger the slashing conditions, then you will relinquish access to your staked assets. You will lose them. And also with the smart contracts, it's defined that ETH stakers, so ETH stakers with native staking or LSTs, opt in validating specific AVSs. They can choose the AVSs they want to validate and commit to additional slashing conditions to their staked ETH or LSTs. So they add on top of the slashing conditions that are already there because of the Ethereum staking protocol, they add the slashing conditions that have been defined by the AVSs. And why? Well, because there will be economic incentives. But we'll see more in detail the economics. But this is what the smart contracts do. And another important, let's say, implementation detail that makes restaking in EigenLayer more specific than just programmable staking in a very generic definition is the support for stake delegation. This is very important because we can already expect, and it's clear, that in most cases, the restakers that in the normal programmable staking definition, the restakers would need to run the additional services, the AVSs. In this case, with stake delegation, often, or in most cases, the restakers will not run directly the software to validate the AVS. They will not do that themselves, but rather delegate this task to professional staking providers who validate the AVS for the restaker and take a share of the rewards. So, stake delegation, in the sense that it's clear that there will be a separation of roles, and the restakers, the ones that provide the assets to be restaked, will not need to run the software themselves, but they can just delegate. Okay, let's say something about the restaking economics. It's important to clarify immediately, then we'll go a little bit more in detail. But how does this actually work? How do you reach an equilibrium from an economics point of view? So the equilibrium is based on a supply and demand for cryptoeconomic security. Remember, this is what we're talking about. Programmable staking is all about offering a way to to rent cryptoeconomic security. So that's the resource that we're dealing with in restaking. So the supply of cryptoeconomic security comes from the restaker, whoever controls staked ETH or LSTs. And the demand comes from the AVS. Remember, the AVS is here because they need a way to get decentralized trust, and in this particular case, more specifically, cryptoeconomic security. So there is a supply and demand that at some point there will be an equilibrium. The AVS offers economic incentives to the restakers because they want to convince them to opt in to restake on that particular AVS. And restakers offer this staked ETH, and yeah, they like the incentives, but they know that there are risks in the sense that if they don't do the validation properly, or better said, if whoever they delegate to don't do the validation properly and trigger the slashing condition, then the restaked ETH is at additional risk because it will be slashed. At this point, restaked ETH can be slashed either by the Ethereum or the AVS. It's also important to know that a restaker can restake the same ETH for multiple AVSs. Okay, now let's move to the EigenLayer stakeholders. For me, it's always very important to know who are the different actors in a system and how they interact. So we need to be aware of at least these four entities. We have the ETH stakers, basically whoever holds claims to a staked ETH, either by an LST or by native staking, ETH stakers. Then we have the AVS operators, the AVS developers, and the AVS consumers. And the decentralized trust layer that is dealt with in EigenLayer comes from ETH stakers and the AVS operators, because the AVS operators are the entities that actually run the AVS nodes. And typically, the ETH stakers delegate to the AVS operators. So the ETH stakers don't even choose directly the AVSs, but they rather choose the AVS operators they want to delegate their staked ETH to. So you have this decentralized layer that is built by reliable infrastructure that is coming from the AVS operators, plus valuable assets at stake, the ETH stakers. This is trust in this model. It becomes decentralized trust as long as the set of AVS operators is decentralized enough, for instance, among other things. So that's these two entities, the ETH stakers and the AVS operators. Then you have the AVS developers, and the AVS developers are the ones that have an idea for an application, and most often for good middleware, and need to get this decentralized trust. To get it, they deal with AVS operators in the sense that AVS developers define the economic incentives to convince the operators to run the node, and the node then, the AVS operators will define the fees for these stakers, and yeah, this is the flow of deals and interactions. And then on top you have the AVS consumers, and the AVS consumers are typically the decentralized applications. So decentralized applications powered by AVSs deal with the developers, with the AVS teams, the AVS developers, who deal with the AVS operators and by delegation with the ETH stakers. So this is the decentralized trust layer, and you have the AVS layer and the decentralized application layer. Okay, now that we have defined the different entities, the different stakeholders, these four stakeholders, it should be more clear that at the end of the day, what EigenLayer is a coordination layer. EigenLayer enables these entities to find an equilibrium, to Basically, EigenLayer coordinates and matches developers, stakers, and operators according to their needs. So these are the different entities, and you have to find this coincidence, this matching of needs between all the different entities. So what do they want? Let's start from the AVS consumers. These are the decentralized applications. What do they want is good middleware, because they know, so for instance, the easy example of the restaked rollup, rollups can become much better with some specific good middleware. So the AVS consumers, the rollup, will look in the market for good AVSs. Then you have AVS developers, and these are the middleware developers. They want decentralized trust to provide value, because the thesis, again, is that decentralized trust is the way to build decentralized applications, or in this case, middleware for decentralized applications, and you need some way to get this decentralized trust. So the middleware developers know that in this model, they know that an AVS is a good way, because you access programmable staking, you access decentralized trust via restaking with EigenLayer. Then there are the AVS operators, and these are typically big staking providers, and well, they just want more business. They have an infrastructure, they have a team that is used to run proof of stake networks. They might want to scale their business, and these AVS operators are looking for interesting or profitable AVS to run. And then finally, you have the ETH stakers that want more options for yield. So they might want to explore different points in the risk-reward curves, and thanks to this coordination layer, they can find the right options. So that's what really EigenLayer does. Puts these people, these entities together, and allows them to coordinate in a decentralized way, in an open way, in a transparent way. And another very important concept for EigenLayer, when you think about EigenLayer, is that EigenLayer is, at the end of the day, also, it's a marketplace for trust. Because, again, decentralized trust is the resource here. And more specifically, cryptoeconomic security is the resource. And there is a marketplace, because this coordination layer allows the different entities, the different stakeholders, to find an economic equilibrium, depending on supply and demand, depending on the needs. And so, at the end of the day, there will be a price for decentralized trust. So, there are at least two deals. I split in these two sets of deals, because on one side, you have the AVS developers, so whoever is building the AVS, they define a kind of service agreement. So the AVS, and this will be a service agreement for AVS operators, and these are the infrastructure providers who will run the node. So the developers, the team, defines these terms for the staking providers. And these terms include this set of conditions. So you have registration conditions. This is the team, the AVS team, that decides registration conditions. Requirements on who can join as an AVS operator. Because, and I want to clarify, EigenLayer wants to be eventually as permissionless as possible and allow any AVS to define their terms on anything. So this, I guess, will come with time, but I like to talk in general about EigenLayer and what they want to build. So requirements on who can join as an AVS operator, and this can be more or less flexible, but this, I want to give you the concept. Then there are staking conditions, requirements on which assets can be staked. And we know that in general what is accepted is staked ETH and LSTs, but the AVS developers might fine-tune these eligible assets conditions and say, no, I want only these specific LSTs, or I only want native ETH, or I only want solo stakers. And that you can see it also as a registration condition, actually. You say, my AVS operators should be only solo stakers. Then you have slashing conditions. So the AVS operators would be slashed if they misbehave, meaning that in these terms, in these service agreements, the developers of the AVS clarify what are the conditions that trigger a slashing event. And also the payment conditions, in the sense that the AVS team has to clarify how the AVS operators and then their delegators, so at the end of the day, the stakers, would be rewarded for the service of running the AVS node. So the AVS developers define these service agreements, these terms, and the AVS operators check all the available AVSs and their service agreements, and they decide which services they want to support. That's why there is a marketplace here, because there will be an equilibrium at some point, because the AVS developers that need more cryptoeconomic security might increase the payment conditions, might increase the incentives. And again, it's supply and demand. And then you have another deal here between AVS operators and ETH stakers that decide to delegate to AVS operators. So the AVS operators will define the fees on the delegated stake, or at least on the rewards coming from the delegated stake, and AVS selection criteria, or anyway, a list of AVSs they want to run. And the ETH stakers will look at these service agreements and decide which operators they want to delegate to. That's the other side of the marketplace. At the end of the day, what for me it's very nice to realize that is that EigenLayer in this way enables price discovery for decentralized trust. If this marketplace is efficient, we can find an answer to the question of what is the value of decentralization. Of course, this just, let's say it will be a data point and it's early, and the value of decentralization is something that will evolve over time with better infrastructure and so on, but it's good to have a kind of idea from this kind of marketplace. Okay, then let's move to other topics, like a little bit more in detail on the implementation, certain concepts. And I took this picture from the EigenLayer white paper to discuss about the concept of pooled security. So what does it mean, pooled security? It means that for AVSs, it's easier to have access to a larger amount of cryptoeconomic security. So you have the word, the word before programmable staking or restaking and pool security with EigenLayer, and then the word with EigenLayer. So let's say before EigenLayer, if you are a middleware developer, you have to find a way to source cryptoeconomic security, and let's say you get 1 billion. And in the word with EigenLayer, you can access a larger pool of cryptoeconomic security. Why? Because the same staked Ether, the same staked assets can be used to secure more AVSs in parallel. It's sufficient that the ETH stakers subscribe to more AVSs in parallel. And then they get all the slashing conditions from all of them. But after that happens, then to attack a single AVS, you will need to gather a level of resources, of economic resources, that is much larger than what you would have if you were playing alone. That's the idea of pooled security. But then there is also this concept of attributable security that is very important to know, because let's say attributable security doesn't exist and you only have pooled security. In a pooled security system, let's go back. In this pooled security system, if let's say there is some staked ETH that is subscribed to all the AVSs, then if the operator related to that staked asset is slashed because of any one of these AVSs, then this security is decreased for all the AVSs. The total pool is decreased for all the AVSs. And this is sometimes not ideal, because maybe an AVS wants to ensure that they have a specific pool of attributable security that is dedicated only with that AVS. Well, this is possible, or at least will be possible at some point in EigenLayer, as an AVS can buy or rent for a certain amount of time attributable security. And it's a concept really similar to insurance, because what you actually buy will be slashing redistribution rights. So I want to clarify immediately that this is not an either or, it's not alternative. You always have pooled security as an AVS, and you can buy on top of that attributable security, that is this insurance. So unlike pooled security, attributable security is specific to each AVS, depending on when they buy it, and will only be slashable by one AVS. This is the very important thing. When you buy attributable security, you buy slashing redistribution rights. You are able to do whatever you want with the amount of assets that have been slashed. Let's say there is some rogue node operator, or anyway an attack, and the attack is detected, the slashing conditions are triggered, and then there will be like this amount of staked ETH that would be slashed because of that. If you have both attributable security, then you as an AVS will have the claim on what to do with this slashed Ether. So for instance, the AVS would be able to redistribute the restaked capital that was slashed to the parties affected by the conditions that triggered the slashing event. So for instance, let's say you're a breach and there is an attack and some value is stolen. Now you can get the slashed ETH from the attacker and you can redistribute it to the entities that have been affected. That's the power of attributable security. And again, this is something that you can buy optionally and will be on top of pooled security. Let's move to the applications for examples of actively validated services. So we said at the beginning, AVSs are mostly about middleware, because that's when they're particularly useful. Because for other applications, it's enough to deploy a rollup, for instance. But anyway, what I was saying, so we said AVSs are particularly suitable for middleware, and indeed, when you look at examples of actively validated services, either in theory or also in practice, as you can see, teams that are already building good middleware on EigenLayer, you can find rollup services, and this is a list of different auxiliary additional services for rollups. And there is this term that is important to know, is the restaked rollups. These are rollups that use one or more of these AVSs. And here you will find things like data availability. It is a service for rollups, like EigenDA. Decentralized shared sequencers, fast finality layers for interoperability, MEV-aware services, watchtowers for detecting faults in optimistic rollups, best confirmation, and so on. This is a set of potential rollup services to build rollups, restaked rollups. Then other options, other possibilities with AVSs, you can build co-processors, Oracle networks, Keeper networks, and bridges. So the idea is that AVSs are and restaking is a particularly good way to get cryptoeconomic security if you're building one of these kind of applications or of middleware. And the last slide I have is on the dual staking model. This is also a very nice application that tells you a lot also about the kind of cryptoeconomic security that you can get and why I say that it can be more flexible and more stable than building your own layer 1. So if you have your own layer 1 secured by proof of stake with your own native token, then suddenly you are very dependent on the value of your own native token. And it's not something that you can easily predict, and it has so-called death spiral risk. I've taken this slide from the EigenLayer blog, so you can find more details here. But it's true, I mean, if the token price of your own staked native asset falls, then the chain security is affected, and the reduced chain security might induce a further decrease in price of the native token, and this can go very bad very fast. So the idea with dual staking model is to add to the security from the native token, also the security from a restaked other asset. And the fact that it's external has definitely some advantages. Using ETH in particular is of course attractive because Ether has a more stable value, it's well distributed, you can tap in the Ethereum community, and there are clear advantages here. And with this model, you can build more complex models, like you can choose the weight in how the native token and the external token both contribute to the quorum. You can decide if using the external token similarly to mesh security or only for a second line of defense for vetoes and these kind of things. But the possibilities are endless. And I think this is my last slide, and I hope this was useful. I really enjoyed talking about programmable staking, and I already want to do a second part on decentralized trust in general and different trade-offs. But that's for another story. Thanks for staying with me, and let's discuss on X. Bye bye.